All right, so today we're going to have this week we're going to have a discussion about the history of computing devices, today and Wednesday. The first earliest known computing device that we know of is the tally stick. Here's an example of one. It's basically marks made into, in this case, a baboon femur to count things. This dates back to about 35,000 BCE. And could be used for basic counting and multiplying by rows and columns and that sort of thing. Obviously, written records weren't available at the time, so the exact usage and application of the tally stick is not recorded. We can just guess. Later on, they used clay spheres, clay cones, and other shapes to represent different items that were counted. These were known as calculi, or are known as calculi. But of course, our you shouldn't neglect to say our probably most primitive form of counting device is our fingers and toes. That's why we use base 10 in most numerical systems. But a clay sphere might represent 1. A clay cone might represent 5. Whatever. But it was used for counting and storage of information by keeping them in, grouped together. The abacus was first developed in Babylonia as early as 2700 or 2300 BCE. Around the same time, the Chinese abacus was developed. That's what the picture I could find was the Chinese abacus, but used beads on rods to represent numbers, and you could do simple addition and subtraction on these. Representing numbers was groups of 5 here and 1s here. So this is 5 plus 1 is 6. This is 0 plus 3 is 3. 0 plus 2 is 2. 5 plus 2 is 7. And so on and so forth. But you might have played on something similar when you were a child, when you're a baby. They're pretty common children's toys nowadays. But those were developed fairly early. Ancient Roman and Greek devices include the astrolabe and the Antikythera mechanism, which were used to calculate the position of stars and planets. We've a common thread in a lot of science is fascination with space. So calculating the movement of stars and planets and stuff was an early fascination by civilizations around the world. Fascinated by the night sky. Muslim world inventions. They made some pretty interesting stuff. The steam-powered automatic programmable flute around 850 CE, invented by the Banu Musa brothers, was possibly a first as far as being a programmable device. It could play music, programmed music, using a flute type of mechanism. The planisphere, around the year 1000, invented by Al-Biruni. The equatorium, the planisphere and the equatorium, again, calculating movements of stars and planets. The castle clock was hydropowered astronomical clock around the year 1206, invented by Ismail al-Jazari. I don't remember the exact names, but Muslim mathematicians and scientists are credited with creating a lot of the math that we use. The 10 numbers that we use are Arabic, based on Arabic numerals. The word algebra is a anglicized version of a Muslim mathematician. I think his name was Al-Jabra. I don't remember. Algorithm is another anglicized word that was a Muslim mathematician that worked with early algorithms and processes. So we get a lot from the Muslim world as far as inventions and math-related topics. Far Eastern, in China, they had the clock tower of Susung around 1094. It was an astronomical clock, again, with astronomy. Fascination wasn't just Eastern or Middle Eastern, it was Far Eastern as well as everywhere. Native Americans were fascinated by the stars and movements of planets and stuff like that. They didn't develop written language until much later, so a lot of that is unfortunately lost to history. Renaissance calculating tools. John Napier discovered the relationship between logarithms and multiplication and division. You can do multiplication and division by adding and subtracting, respectively, the logarithms of numbers. So he created what's called Napier's bones, an abacus-like device that simplified calculations involving multiplication and division. Shortly after Napier's work, the slide rule was invented in 1620. William Oughtred invented the circular slide rule in 1630, and he followed it up, but with the what we know now as the modern slide rule in 1632. Now, the slide rule was used as a scientific calculating device up until the advent of basically electronic computers in the 1960s. They used slide rules to calculate trajectories of rockets going into space using, a simple device such as the modern slide rule. This one I'm not familiar with the labeling on it, but funny little story. When I was in 8th grade, my father had a slide rule, and he taught me how to use it. And I brought it to class one day for my Algebra 1 class, and the teacher said we couldn't use calculators on the test. So I pulled out the slide rule, and he just kind of laughed and said, "It's not a calculator. Go ahead and use it if you know how." So he let me use the slide rule on an algebra test. But you can use this for use slide rules for doing roots, multiplication, division. Some more advanced ones have some trigonometric functions on them. So you can calculate all kinds of fun stuff with just this simple slide rule. I have one in my office. I forgot to grab it and bring it down to show you. They're typically about yay long, about that wide. But versatile little mechanisms invented in the 1600s. Mechanical calculators. My slide screwed up a little bit. Guido Baldo del Monte made a mechanical multiplier in 1609, created to calculate fractions of a degree. Probably used in navigation, that sort of thing. And it was the first documented use of gears for mechanical calculation. Wilhelm Strickard designed a calculating machine in 1623. It was the first mechanical adding machine, and it used a mechanized form of Napier's rods, a variation of Napier's bones. Now, Pascal invented a mechanical calculator in 1642 while he was still a teenager, called a Pascaline, or Pascal's calculator. And got a little picture of that. It's gears and that sort of thing as well. But they didn't really get to be commercially viable until later. Gottfried Wilhelm von Leibniz said it was beneath excellent men to do basic calculation when it could be done by any Joe Schmo with machines. He invented the stepped reckoner, and he's the first one to describe the binary numeral system, which is central to modern computers. Though the modern computers still used base 10 up until around 1946. They didn't use binary until later than that. Charles Xavier Thomas de Calmer, he's the one that created the first successful mass-produced mechanical calculator. Created around 1820. You could add, subtract, multiply, and divide. And mechanical calculators would remain in use until the 1970s. You know, cash registers, adding machines, that sort of thing. He figured out a way to mass produce it in the early parts of the before really the Industrial Revolution. And the Industrial Revolution, they were able to refine the process and really mass produce them, and they were commercially successful. Now, punched cards as a method of storage. French weaver Joseph Marie Jacquard invented a loom for weaving fabric that was controlled by punched cards. He developed it in 1804, and you could change the punch cards and change the pattern woven into the fabric without changing the mechanical makeup of the loom. Whereas Herman Hollerith had used it for long-term storage, and used a tabulator invented the tabulator and key punch machines to read and write to punch cards. Used in the 1890 census, it was processed 2 years faster than the previous census because it was more automated, using tabulators and basic adding machines. And his company later became the core of IBM. So his company is still around, making computers. And that's it for the first half of the slides. I will be making the rest of the slides for the next session, which will be about general purpose computers, starting with Charles Babbage's analytical engine and differential engine, developed in the 1820s. The first computer programmer, Lady Ada Lovelace. And we'll get up to supercomputers and that sort of thing toward the end of that discussion. But interesting stuff. Interesting to see how far we've come. Even going back, 35,000 years, or 37,000 years. But who knows where we'll be going next with AI and that sort of thing. And quantum computing, that's another thing that I was going to put in there, some of that.